on smart irrigation system. So as we all know, irrigation, in irrigation we have water. So water is essential thing in life, and as well it is very important in agriculture too. So we are going to discuss a case study on how a smart irrigation system is done, because in traditional irrigation system the water is wasted and it is very inefficient. So we are going to use the sensors and the IoT devices to make a smart irrigation system. So now Christy is going to give the objective part of smart irrigation system.
Let me give the objective of smart irrigation system. It reduces water consumption while ensuring optimal soil moisture. With the help of these three sensors, it automates the irrigation schedules for the crops to be irrigated. It enables real-time monitoring and controls through a mobile application. It provides actionable insights to farmers to improve crop yield.
So I call Hamish now to give the introduction of smart irrigation system and the architecture that is available.
Let me give the introduction about the smart irrigation system. So agriculture is one of the vital role in the economy. So in this agriculture role, the water management is very important to efficiently manage the plant crops with the watering. So if the watering the plants is excessive, it provides a higher operational cost. Or if the watering is not adequate to the plant, so it is also affecting the crop yield. So to address this issue, so we use the smart irrigation system. So this smart irrigation system has an architecture. So it has three sensors. So soil moisture sensor and temperature sensor and humidity sensor. So these three sensors are placed on the field of a farmer land. So the soil moisture provides a moisture about the soil. Okay. So every soil has a certain moisture. So if the farmer has a neighbor, so like neighboring difference in the moisture. So that we use the soil moisture sensor. So next, temperature sensor. So the temperature sensor provides an atmospheric temperature. So like in every state the temperature will be different. So to measure this temperature, the temperature sensor actually useful. Okay. So next, the temperature sensor. Sorry, humidity sensor. So humidity sensor provides an moisture about in the air, like how the water spreads in the field. So like it is very snow or it is very hot, like that the humidity sensor will predict. So these three sensors will connect into your microcontroller. So the microcontroller is based on like Raspberry or Arduino. So it is an embedded system, like it has a software code like C or C++. So like the program we feed into the microcontroller. So these three sensors connected with the ports of a microcontroller. So this processes the analog or digital signal coming from the three sensors. So the microcontroller can communicate with the three types of actions. So first action is water pump controller. So the water pump controller is the main action performed in the smart irrigation system. So and then the microcontroller. So microcontroller has a communication system and then Wi-Fi GSM model and power supply. So the power supply provides a main supply to the microcontroller to run up the microcontroller and sensors and other products. So in the components in the irrigation system. So the Wi-Fi, when you prefer a small operating range, the Wi-Fi is easy to manage, and with the controlling the smart irrigation system large, we use the GSM model. So the GSM model provides a cellular network functionality to communicate with all over the world with have a network internet. Okay. So next, if the data is in higher of these three sensors, so the cloud servers we introduce. So the cloud servers like a Firebase or AWS, so that has a variety of services to store the data. So like sensors, it has a more than one value or more in a field of day to day. So there are different temperatures or different humidity or soil moisture of different levels. So we want to analyze and make some intelligence in it. So that's why use the cloud service server. So these are all components will connect with the user interface. So this user interface provides all controls to the smart irrigation system. So the user interface like when to switch on the water pump. Okay. So at certain which level the temperature heat the water pump should turn on, or certain monster level indicates as something we need to turn on. So something we need to take an action for this. So that's all the architecture of the smart irrigation system.
So I hope Hamish gave a brief introduction of smart irrigation system and the architecture used. Good work, Hamish. So now Arun Kumar is here to define the implementation part of the smart irrigation system.
So now explain the implementation on this smart irrigation system in the real world. So in the case study we take the delta areas, because the delta areas near of water is high level and the rainfall is also very low. So this smart irrigation seems to the plants to grow in very good yield with the small amount of water. So first of all implement on these sensors on the land and then hide the data from the plants, from the soil and temperature and humidity, and then next process the data via the microcontroller. Microcontroller process the data and then give the conclude of the pump is on or off. So based on this conclusion, the pump will be on or off. So during this time, the water consumption of the plant will be very low. So when pump is very low, soil moisture and temperature is very high and the humidity is very low. So the microcontroller processes the data and then to give the command to the water pump to turn on the water pump. So during this time, that time only the water will be passed on the land. So after that reaches some threshold limit, that water pump flow is stopped. So and then next this data, microcontroller data will be also stored on the cloud server. Okay. So because of the backup data, this is the implementation of the real level, and then the automation system implement on the future, because the automation system without the interface of the farmer or farmers automatically turn on the switches and of the motor, and also the without user interface mobile app, we automatically turn on and turn off the motors and to help without human interface to operate all the systems on the smart irrigation. That's all.
Thank you, Arun. So Akhilesh, can you give what is the resultant part of this smart irrigation system?
The result of the smart irrigation system is first water savings. Water is saved up to 30 to 40% as compared to the traditional irrigation methods. And the second one is crop yield. Crop yield is increased up to 15% than traditional methods. The third one is farmers' feedback. Farmers are reported ease to use and reducing in crop failures.
So we have seen what is smart irrigation system. So to conclude, smart irrigation system is not only just a technology upgrade. It does not support the farmers for water consumption alone, but it uses many technologies like sensors, IoT devices, and different data analytics to predict how much to water the crops at right time, at the correct time, so as to improve the productivity of the crops. As well, it also makes the agriculture a sustainable and a productive.